video, we're going to answer the question, how do we know if two LOBs have common drivers? And what do we actually mean by common drivers? So let's go to the tree structure in your database, workbook 104A. There's a variable called exemplary. Let's drill down by looking at the branches. So click on the plus sign, select common drivers. Let's open this basic triangle group, gross versus net. Now, a basic triangle group can contain, apart from data sets, also composite data sets. So click on composite data sets, and you'll see there's one triangle called gross, one triangle called net, one is net of reinsurance, one is the gross data, and you'll see that they're very highly correlated. So let's now go to the Models tab, and under the Models tab, you have your basic models. There aren't any, but you can also click on this button called Composite. So it'll be Models, Composite, and we have a model called Good 2. So let's run it. Now we want to run the same model again, but in a different window of MPTF. There are two ways we can do that. You can either click on the triangle group tab with the right button of your mouse to go back to the triangle group and just run Good 2 again, and it will run by default in a new window. Alternatively, you can go back to the MPTF module, right button of your mouse on the MPTF tab, select the module you're currently in, then go Model Load, Load Model with a downward arrow, and Load Model in New Window, and select Good 2. Now tile vertically, minimizing other types, and on one of them you've got a gross model and net model, and one of them select net. So you're comparing the net trend structure with the gross trend structure. Let's look at it versus calendar years, and you can see the structure is the same. Let's look at it versus development years, and the structure is the same. Along the accident years, in the early accident years, the structure is a little bit different. But in the later accident years, it's very similar. Now let's look at the residuals. So with the right button of your mouse, click on the residual button, the one with the diamonds, green diamonds, select all, tile vertically, minimize other types, and let's just look at the residuals versus calendar year. And you can see the middle blue rivers are very similar in terms of ups and downs. Now what we want to do is create a trace of the calendar year 2006. So we want to collect the 2006, connect the 2006 residuals by a blue line. So click with the right button of your mouse on the little blocks above 2006, and also on the other side. Now let's look at the residuals versus accident years. In each residual graph, you can also remove the points. Click with the right button of your mouse on the white, and remove the tick on sharp points, and do the same thing on the other side. And you can see that the ups and downs are very highly correlated. If you want to examine the value of the correlations for all the residuals, just click on CO. I mean, both models in each one are the same, so click on CO, and the correlation is 8.5. What we want to do now is go back to versus calendar years in your residuals, and we want to just remove all the calendar year parameters except for the first one. In other words, we're just going to measure the average calendar year trend for both net and gross. And then we want to see the correlation, the residuals. The correlation, the residuals then will be the process correlation plus some of the trend correlation. Okay, so let's, and the way to do that is you go to the bottom left corner of the residual graph. There's a little gray box. Click on it, It removes all parameters except the first one, and do the same thing on the other side. Now with the right hand click of your mouse on the E button, select all. So it's estimating both. And here you can see very strong correlations between the two. But that's basically the sum of two correlations. The trend correlation, the trend parameters along the calendar years had the same structure, plus on top of that the process correlation. So if you now click on CO, the correlation increases to 0.8. Let's look at the various types of correlations. So I'm going to go back to my Microsoft display, and let's me bring up the pointer, highlighter, and also in color. The first kind of correlation we've learned about is process correlation between two sets of residuals. That induces parameter correlation. But then there's the worst kind of correlation you can have, which we call same trend structure, especially along the calendar years. So if we go back, if I go back to Ecofus, and now with the right button of your mouse on the model load, select all and load model good too in each case, and now look at the model display, right button of the mouse on the model display button, select all. If it's already tiled vertically, minimize other types, you can do that. And look at the calendar years. See, if they've moved in the same direction in the past, they'll move in the same direction in the future. And that kind of makes sense with net and gross data. If there's an increase in trend in the gross, you suspect there'll be an increase in trend in the net data, a change in trend in the net data. So that's the worst kind of correlation you have, which is number 3. That makes sense. Okay. And then we have what's called reserve distribution correlations. Now, one induces 2. So number 1 induces parameter correlation. 3 is the worst kind of relationship you can have between two LOBs, as it results in very little, if any, risk diversification. Because if you have 3 trend structure that are very similar, then you'll also have high process correlation. In that case, the reserve distribution correlation will also be very high. So if 2 LOBs satisfy 3, then 1 and 2 are going to be process correlation, parameter correlation are going to be close to 1, and reserve distribution correlation is going to be close to 1. Fortunately, number 3, we only observe between layers of the same LOBs, between segments of the same LOB. LOB1 and LOB3 that we modeled in a previous video, in fact, were the same line, but for different states. And between that of reinsurance and gross data. Okay, so very often that you find when you look at 2 lines of business, they don't have the same trend structure. They have very often 0 process correlation, which means 0 parameter correlation, which actually means very low reserve distribution correlation. The reserve distribution correlation is typically much less than the process correlation. So the highest process correlation I've seen is about 0.6, and the corresponding reserve distribution correlation might have been 0.2. So let's go back and just mention something else. Very often, if you look at a net of reinsurance triangle and a gross triangle, in some cells the numbers are the same. And we're kind of advised that if you're modeling gross and net and you want to know the distribution, the reserve distribution for gross and the reserve distribution for net, you should in fact set the correlation to 0, because otherwise you're kind of pulling yourself up by your bootstraps. You're getting sort of kind of information where you're doubling up on the information. So let's suppose we go to one of these models, model good 2, either run 1 or 2, and then set the correlation to 0. So you go to OC, set all correlations to 0, and now save that as good 2, 0 correlation. And if I do the forecast now, okay, these are kind of answers you'll get in PTF, aren't they? And you got a forecast summary button, then the gross and net reserve distributions are the kind of distributions you'll get in PTF. However, if you wanted to find a kind of correlation between these two distributions, what you might do then is use the model good 2 in this particular run number 1, where we didn't set the correlation to 0. So if you click on CO, the correlation process 0.85. If you do the forecast now, you got a forecast summary. You go to summary by data sets tab under aggregate, and you can look at the correlation. So the reserve distribution correlation between net and gross is 0.74, but I'm not too sure. In fact, I'm sort of averse to using these gross distributions and net distributions. So we're going to go to summary, summary tab, the net and the gross as the distributions of the gross reserves and the net reserves. And there might be some more discussion of this sort of this effect on our website under demonstration videos. Alternatively, you can always send us support questions if you're not too sure about any of the arguments we present in the training videos. Okay, thanks.